All right, so here we have a couple different angles drawn. And if you remember back to our last video, we can label these angles with the letters. So we have angle ABD, and that is this large angle right here. And if you remember, this symbol right here, the square in the corner, tells us that it's 90 degrees. So we have angle, remember this means angle, ABD, and that is this 90-degree angle right here. And then we also have angle ABC. That is this small angle at the top. So we have angle ABC, and then we have angle CBD. So today we're going to talk about something called complementary angles. And complementary angles are when two angles add up to 90 degrees. So in this case, we have the big angle, which is 90 degrees, and then we have these two smaller angles within this 90 degrees. So these two smaller angles, ABC and CBD, add up to 90 degrees. So we could say angle ABC plus angle CBD equals angle ABD. Let's take a look at this example right here. It says, what is the measure of angle DBC? So when you have an M in front of this angle sign, it just means measure. So we are actually talking about specific angle measurements here. If we look for angle DBC, DBC is this angle right here. We have DBC. So we want to figure out what the measure of that angle is. We know that complementary angles add up to 90 degrees. This big angle right here, angle ABC, is 90 degrees, and we know that from this marking right here. We know that these two smaller angles have to add up to 90 degrees, and it gives us what these two smaller angles are. So we know that 2x minus 4 less x plus 7, if we add these two angles together, we will get a total of 90 degrees. So now we have an equation that we can solve. If you need some reminders on how to solve one-step or two-step equations, we have some YouTube videos on those, and you can go check those out. We will go over step by step, though, how to solve this equation here today. So the first thing we want to do is we want to combine our like terms. So we have some x's that we want to combine, and we have some constants that we want to combine. So we have a 2x and an x. We combine those, we get 3x, okay? And then we have a negative 4 and a positive 7, and we combine those, we get positive 3. And that is all equal to 90 degrees. So now we want to tell the story of x. So if we say x started all by itself, it was first multiplied by 3, and then we added 3 to that. So we are going to start at our last step and work backwards. So if we added 3, we are going to do the opposite and subtract 3 from both sides. So we'll have 3x equals, because this goes away, 90 minus 3 gives us 87. And then we're going to come to this step right here, and we multiplied by 3, so we're going to divide by 3. So we have x equals 29. So now that we know the value of x, we can plug it in to this equation right here to figure out how many degrees this angle is right here. So we will replace this x with 29. We can figure out what the whole angle measurement is here. 29 plus 7. 29 plus 7 is equal to 36. So that tells us that this angle right here is equal to 36 degrees. And let's say they wanted us to find what ABD was as well. So we could plug in 29 into this equation and do that the same way, or we could use what we know about complementary angles. We know that they have to add up to 90 degrees. So if we know that this angle, DBC, is 36, then we can say 36 plus whatever this angle is here has to give us 90 degrees. So we can do 90 minus 36, and that will tell us what this is. So 90 minus 36 is equal to 54. So that tells us that angle ABD is 54 degrees.
Now that we've talked about complementary angles, let's talk about what if we put two complementary angles together. If we put them back to back. This is complementary, or 90 degrees, and this is complementary, or 90 degrees. We see here we have what is a straight line. So this all together adds up to 180 degrees. So this is what we call supplementary angles. Supplementary angles are any angles that add up to 180 degrees. Here we have angle LMP, and we also have angle PMN, or we can also say NMP. Either way, so angle PMN, and that would add up to 180 degrees because together this angle plus this angle makes a straight line or 180 degrees. When they are joined like this, we call this a linear pair because they are a pair that makes a straight line. So that's a special name for supplementary angles when they are adjoining each other to make a straight line. You can also have supplementary angles that look like this if I were to separate that, but they just weren't connected. These would also be considered supplementary because if I joined them together, it would make that 180. Here in this example, we want to find the measure of angle MNP. MNP, looking at our picture here, is this angle right here. So we know it is 3x, but 3x is not the measure of our angle. The measure of our angle is how many degrees is it. So we need to solve for x. Luckily, we can use our angle relationships over here to figure out what kind of equation we can set up in order to solve for x. So these are not complementary angles because they do not make 90 degrees, but they do make a straight line. They are a linear pair. So I know that the relationship between this angle and this angle is that they add up to 180. I'm going to say 7x plus 3x equals 180 degrees. I can combine like terms. 7x's plus 3x's gives me 10x's total equals 180, and then I can use undoing 10 times x. To undo a times 10, I can divide by 10, and I'm left with x equals 18 degrees. That doesn't mean that the measure of angle MNP is 18 degrees. It just means that x is equal to 18 degrees. I know that instead of 3 times x, I can swap it out for 3 times 18. So I know that the measure of this angle here is 3 times 18, which is the same as 54 degrees. So geometrically, we would officially say the measure of angle MNP is equal to 54 degrees. We could easily figure out how many degrees is angle JNM if we plug in 18 for x and do 18 times 7, or we could also use the supplement to help us find the other angle. So we know that this angle plus our 54 degrees adds up to 180, so we know that it's 54 degrees plus blank equals 180, which gives us 126 degrees. So we know that this angle is 126 because it's a supplement to angle MNP, which was 54 degrees. What if we have two lines that are intersecting? We're going to investigate the relationship going on here. So here we see we have line AB intersects with DC, and the point of intersection is here at E. A new angle relationship is what we call vertical angles. Vertical angles are angles that lie directly opposite of an intersection point. So in this example, angle AEC and angle DEB are vertical angles because they lie opposite of this intersection point. This angle is vertical angles with this angle. So these two angles are vertical, but notice that the top and bottom here are also vertical angles because they lie opposite of this intersection point. So we would say that angle AED and angle CEB are also vertical angles because they lie opposite of the intersection, and these two lie opposite of the intersection point. All right, let's talk about a special feature that vertical angles have. Notice that B and C, they look like they're the same size. One way that we can prove this is through rigid transformation. If I trace out angle B here and I rotate it 180 degrees or a half turn, notice that it lines right up with C. So we know that angle B and angle C are congruent. So that is one way we can prove that. We can also prove this algebraically. We can see here that A and B actually form a linear pair. So we know that A plus B adds up to 180. And similarly, we can do the same thing for A and C. A and C add up to make 180 as well. Because both of these pieces are equal to 180 degrees, they are equal to each other. That's called the transitive property. So because they're both equal 180, they're equal to each other. So I can rewrite this as A plus B equals A plus C. I can simplify things down to prove that B and C are indeed the same size. So since they have an A on both sides, I could take away an A from both sides. So I'm left with B equals C. And now we've proven algebraically that these angles or vertical angles are always congruent.
Now that we understand the definition of vertical angles, we can use that to solve for x in this situation. If we see this angle right here is vertical angles with this angle up here. So we know that 5x minus 7 is equal to 3x plus 5. They are opposite of the point of intersection. So we can say 5x minus 57 is equal to 3x plus 5. And we can solve this. The first step when solving equations is we want to get all of our x's on the same side. So I have a 5x over here and a 3x over here, and I want them all on the same side. So I'm going to subtract 3x from this side, and that becomes 0. But then I have to subtract 3x from this side. 5x minus 3x is 2x minus 57 is equal to 5. We want to undo this equation. So we're going to start here with this minus 57. We're going to add 57 to both sides. This becomes 0. 5 plus 57 is going to give me 62. So I'll have 2x equals 62. And then my last step is to do the opposite of multiplying by 2 and divide by 2. This becomes 1. So I'm left with x equals 31. So now I know that my value of x is 31 degrees, but I want to know what each of these angle measures are. So I can take this 31 degrees and I can replace x with 31. 3 times 31 plus 5. So 3 times 31 is going to give me 93 plus 5, 98. And because these are vertical angles, I know that this angle also has to be 98 degrees, but we can check it just to make sure. So we can say 5 times 31 minus 57. 5 times 31 is 155, and then we'll subtract 57 from that, and that will give me 98 degrees. So we know that these two angles are congruent.